Hey guys, I'm Justin, representing Group 5, and today I'll be presenting the results of our mini project. Here's the content, and let's dive right in. For our project, we created a mass spring damping system using Legos and sensors. We first built a Lego framework with rubber bands acting as the springs and ropes acting as dampers. The position of the load during oscillation was measured using a proximity sensor connected to an Arduino board with the code uploaded. After the setup, we faced some problems saving the data with the serial plotter and serial monitor in Arduino. To make data recording more convenient and efficient, we introduced a new approach using the data streamer add-in in Excel. This allowed us to capture, visualize, and analyze the real-time sensor data directly in Excel. Then we conducted experiments by releasing the load from 3 different initial positions, and the videos show the first case where the load is released from the bottom, and we also used the virtual platform to simulate this process. We found that the highest release point resulted in smaller amplitude and frequency in oscillation. This actually makes sense because a smaller displacement generates a weaker restoring force, leading to a smaller oscillation. Next, we modeled the mechanical system as a 1 degree of freedom linear system and applied Laplace transform to the ODE. We first weighed the actual load mass, and by adjusting the damping coefficient and spring stiffness, we found the best fit to the experimental data when the damping coefficient being 0.18 and spring stiffness being 7. We also explored 3 extension studies. Increasing the mass reduced the amplitude and frequency, which can be explained by the increased inertia. Secondly, as shown in the video, we increased the damping coefficient by changing the load structure to create more resistance between the load and the 4 ropes. Both experiment and simulation show overdamped with no oscillation. Finally, by obtaining the transfer function, we also obtained the pose of the system. Well, our project has some limitations such as the unstable sensor, the Lego platform, and accuracy of the feed approximation. It opens up opportunities for further improvements. So in summary, here are the key findings of our mini project, and most importantly, the correlation between our experimental results and the theoretical models confirms the reliability of our approach. So for more details, please refer to our report, and thank you for your attention.